So in problem 1.6, we look at a contract in the continuous time case. So we will look at a continuous benefit and contribution scheme. So what do we assume about the benefits and contributions? Well, the contributions are continuously equal to 1, is what we are told. So C of t is equal to 1 throughout the whole contract, which goes from time 0 up until time 10. So this is C of t. And then we have the B of t, the benefits, which we receive at rate pi t. So what does that mean? Well, t is time, right? So for example, at time 0, pi t would be 0. And then pi t, the graph would be linear with slope pi all the way until time 10. I should probably draw it with a less steep slope, so like that. So this would have slope pi, and this is the benefit rate. So the contributions are constant, whereas the benefits grow and grow and grow. So during the first year, you don't accumulate that much in benefit, but during the last year, you accumulate a lot more in benefit. So what do we assume in this question? Well, we assume that the continuous interest rate delta is equal to log of 1 plus 0.04. And this means that over the course of 1 year, if you pay 1 unit, then the interest you accumulate is 0.04. It doesn't mean that you accumulate delta in interest. Now, what is the goal of this exercise? Well, the goal of this exercise is to find pi so the contract is fair. That's what it says here. Find pi so the contract is fair. Well, that's super. What do we mean by fair? Well, the fairness criterion given in the book states that a contract is fair if the present value at time t of all past net contributions is equal to the present value at time t of all future net benefits for all t. Now, in exercise 2, we established that if the present value at time 0 for all future net benefits is equal to 0, then that would imply the fairness criterion. So that means in our case, we just need to find pi such that v of 0 is equal to 0. So find pi so v of 0 is equal to 0. So find pi such that the initial present value of all future liabilities equals 0. What else does that mean? Well, let us recall that when we talk about future liabilities, we mean benefits minus contributions, right? So we want to find the price pi, or not the price. We want to find actually the kind of like the slope pi such that the benefits will correspond to the contributions that are paid in. And in order to do that, we actually need to know how we can calculate v of 0. So the definition of v of t is given as such in the book, in the continuous case. V of t is equal to the integral from t to n. So what we do is we stand at time t, and then we look at all the future payments that go up to time n. And what we do with them, well, we look at the future net benefits at all time points from t to n, and then we say we will discount them back to time t, and then we will take all of those payments, all of those infinitesimally small payments that are given by payment rates, and we will sum them all together. So this is how we find v of t. So if we want v of 0, I will plug 0 in to all of the places where I have t in the above. So v of 0 is equal to the integral from 0 to n. And let me also just plug in my values for b and c now. So b of s is equal to pi s, and c of s is just equal to 1. And then here I have e to the minus delta s minus 0, which is just 0 up here, so I don't need that. And then ds. And now I want to calculate this integral. First of all, I can notice that I can split it up into two integrals. I have the integral from 0 to n over s ds multiplied by pi, minus the integral from 0 to n. Sorry. No, let's just go back over over s multiplied by the discount factor, ds, and then multiplied by pi. And then I subtract the integral from 0 to n over just the discount factor multiplied by a 1 ds. Okay, so it seems that the hardest part here would be to find the value of this integral, right? The formula we use for that is the partial integration formula, so integration by parts. I will write that formula down for you. I expect you to do the calculations on your own. So the formula says that whenever we have an integral that's on this form, so I have u of s v prime of s ds, then that is equal to, if I take u of s, v of s in the boundary values and subtract them from each other, and then I minus the integral from a to b over u prime of s, v of s, ds. So this is integration by parts, int by parts. And use this to calculate this integral, okay? You can let u of s be equal to s and v prime of s be equal to e to the minus delta s. Because then after a couple of calculations, you should get the following result, that this above is equal to pi multiplied by, and then this next part is what you should get from the partial integration, pi multiplied by 1 over delta multiplied by minus n 2 times e to the minus delta n plus 1 over delta multiplied by 1 minus e to the minus delta n. So that's what the first integral evaluates to. And the second integral is quite easy. That evaluates to minus 1 over delta 1 minus e to the minus delta n. So 1 over delta, and then it's 1 minus e to the minus delta n. Okay, so this thing here is what v of 0 is. And since we also know that n is equal to 10, we can also just plug the value of 10 into all the places where we have n inside here. What's the last part we have to do here? Well, find pi so that the contract is fair. So pi satisfies that this thing over here, this monstrosity, should be equal to 0. So hence, pi multiplied by this thing should be equal to this thing. So pi is equal to 1 over delta 1 minus e to the minus delta n divided by 1 over delta. So these two, they cancel out. And then I have 1 over delta 1 minus e to the minus delta n minus n times e to the minus delta n. Ooh. So it should be equal to this long expression. And after you plug in n equals 10, then you will get that pi should have the numerical value of 0.2139. So that's the numerical result, and the thing with 2 lines under here is the symbolical result.